This is our third day, isn't it? Our second day. Second day. We're going to do chapter one. We're going to do the first three sections of chapter one. And basically, we're trying to do half a chapter each class period. That way, we'll get done with 2 or 3 weeks to spare, and that way we have time to do our work and review. So what we did last time we talked about graphs and stuff and slopes and points. We did the introductory stuff, but I want to talk to you first about a rule I have. I know when you're in school, the teacher said whenever you're solving for a variable, if there's a negative, just divide by the negative. I'm going to try to get you away from that. So for example, what if you had, here's our equation. We're going to do the same on both sides. Again, the rule says never divide by a negative number. Instead, change the signs and then divide by a positive number. But trust me, the less you have to worry about negative signs, the easier this class will be. Because negative signs will ruin your day so many times over. I'll talk slowly so you can catch up. So, on the left side, how would you all do it if I gave it to you as a in-class homework? If you're solving for X, what would you do first? Here are the steps to solve. Move all X's to one side. Check. All the X's, there's no X on this side, all the X's to one side. That's the first thing you have to make sure. Second step. That's where we're getting to today. So how do we get the X by itself? What do we have to do? Subtract 3 from 11. But yes, you're right. The 3's cancel. We have negative 4x. 11 minus 3 is... Hey. Then what would you do? So we get X by itself, we have to get rid of. No, we're trying to get X by itself. So we have to move everything else. Get X alone. So here's X. We want to keep it by itself. So what do we have to get rid of? We have to get rid of the negative 4. How do you get rid of, these are connected how? So what's the opposite of multiply? So how do you get rid of this negative 4? This is the way you were taught in high school, which is, it's not wrong, but more mistakes will happen here. Because look at on this side. You have a straight line here, straight line here, straight line here, straight line here. Eventually, the bigger the equations get, the more signs you'll have, and you'll have a bunch of mistakes there. So the negative 4 cancels. So what does this side equal? Yeah. Whenever you multiply or divide, I'll write this down also. Whenever you multiply or divide, count the number of negatives. Multiplying, divide by signs. Count the number of negative signs. If you have an even number of negative signs. Then your answer will be positive. Conversely, if you have an odd number of negative signs, then your answer will be negative. I'm going to send you all these this afternoon anyway. So for examples, so in this first one, will the answer be positive or negative? Yeah, because we have 1, 2, 3 negatives. So the answer is going to be negative. Since they're all multiplied together, we don't have to worry about the signs anymore. We know the answer is negative, so we just worry about the numbers. Again, treat them separately. How about this one? Positive or negative? 1, 2, 3, 4. So it's positive. All the negatives cancel. So we know it's, so now we just worry about the numbers. 2 goes into 4 twice. 5 times 2 is 10. 3 goes into 9 3 times. 3 goes into 6 twice. So the answer is 2 over 1 or just positive 2. Again, we're going to spend time doing this as well as we go along. Because I'm going to talk to you guys about factoring and things like that. So how to separate numbers, make them into prime numbers. And this one here, because of the rule of commutativity and associativity, how would you multiply this one? You could. So you have 2 times 3 is 6, times 5 is 30, times 1 times 4, 120, times 2, times 2. Yeah. Again, you have to work on your multiplication skills. Keep away from the calculator. Use the calculator to check your answers, not to do your work. Because your brain's a muscle. It's bad enough. Well, you guys are all healthy. Not like me. You don't want your belly to get flabby, so you get your brain the same way. Or you could have done 5 times 2 is 10. 4 times 2 is 8. 8 times 2 is 16. 10 times 3 is 30 times 16. Okay, or you need a combination that way. You can move them. So 30 times 60 is 3 times 16 is 48 with a 0. So you can move them around however you want to, or you can go straight across. All right, so in this one, we only have one negative, so the answer is negative. 8 divided by 4. Of course, 4 goes into 8 twice. Does everybody remember the rules of division of why this becomes 2? What is 8 made up of? Well, we'll do that in a second. I'll show you. This one I'll combine it with here also. So the answer is negative 2. This is the way that I prescribe. Again, same thing, we move the 3 over, subtract 3 from both sides. At this stage, since in front of your x is a negative, change all signs. Since this side's negative, and that's where the x is, let's change the signs. So that becomes a positive 4. This one becomes a negative 8. Change all the signs. Because now, what do you have to divide by now? Only 4. You don't have to worry about, did I put a negative down there or not? Again, the less you have to write at any one step, the easier it is to make a better grade. So we know the answer is going to be negative. 8 divided by 4 is 2. So try to get used to separating the negatives from the numbers. Do them both separately. Again, it's up to you to choose whatever you want, but I guarantee you, keep a log of how many times you make a mistake just because of the sign somewhere. I guarantee you that list will start growing as the semester goes on. Treat the signs and the numbers separately. So far, so good. I'm going to use it as a benchmark. Okay, let's go back to what we did last time. What is a graph? Bless you. Allergic to math. What is a graph? Yeah. Well, information. Pictorial representation of an equation. A graph is simply a picture. Because if I asked you to graph this, what would you do? Yeah, you have a number line. Here's 0. And just put a dot there. It's a pictorial, it's a picture. If I gave you something like this, what is that called? No, it is a coordinate, but what is it called? It is a coordinate, yes. But what's the 2 other names for it? That's 3 other names. It's a point. What else? Starts with an L. Location, very good. Because what's the location of this point? Yeah, start from this middle part, which is called the origin. That's called the origin. What is the origin's location? What is it? 0, 0. Because it has to be, since we have 2 lines, we have to have a coordinate of 2 points. So we go from there, we go to the right. Since it's positive, we go to the right 2 spaces. So that's to the right. And this one is positive, so it goes up. 1, 2, 3. So there is that location of 2, 3. It's always the x direction first and then the y direction second, always. One more name. You have two numbers, so it's called an, those are the graphs. You're close though. They're in a specific what? Another word for format starts with an O. Order. So this is an ordered pair. All of those mean the same thing. If I ask for a location, if I ask for a point, if I ask for a coordinate, if I ask for an ordered pair, it all means the same thing. So you see why it's important to understand the language of mathematics. Because I won't always say, find me the point. So give me the coordinates of this location, or graph this location. Are those 2 points, are these solutions to this? Let's just make it 17 right now. Are these points solutions to this equation? It's a math course. Do we just guess at math, or do we do something else? We do work. So in the first one, we call this one A. What do we do with the first one? First ordered pair. Plug them in there. What is X? And Y? Plug in my X and a Y in the equation and work it out. 4 times 0. Negative times positive. Negative. That's you. 2 times 3 is 6. 0 minus 6. Does negative 6 equal 5? So that's not a point. That's not a solution. A solution are an order, or is an ordered pair that makes it a true statement. How about this one? So let's try this one. What is X? Negative 3 minus 2 times Y is 17. Positive times negative. 4 times 3. Next one. Negative times positive. 2 times 17. So we have 17 times 2. 7 times 2 is 14. 2 times 1 is 2. Okay, I just got 34. Equals 5. Negative 12 minus 34. Is the answer going to be positive or negative? Negative. They're both negative. It would only be positive if I was multiplying the two numbers. But this is I'm subtracting the two numbers, and they're both negative. So if they're both the same signs, I keep the common sign and do what with the numbers? Add the numbers. So 34 plus 12. Does 46 equal 5? So neither of them, no solutions in either of those. Make sense? Again, it'll take practice. Always have a sheet next to you so you do this kind of stuff on a piece of paper. Again, start working out. This is chapter 1. So let's make our mistakes now. Do the work, and then after you finish this, then get a calculator, check if this is right. Because I guarantee you what's going to happen is the more you do this on pencil and paper, the less you will resort to going straight to the calculator at the end. The more comfortable and confident you become with this, the better it gets. So again, if I give you are any of those solutions, you have to check, right? So this is where you guys use your pencil and write things on paper. You need some paper? If you don't ever hesitate to ask, I'll always be more happy to use it. So what do we do with the first one? So what's y going to be? Y is going to be -5. And x is going to be 0. So it's 2 times 0, 0 plus 5. Are they equal? No. So not a solution. So same equation. What's y? And x. Positive times positive is positive. 2 times 3, 6 plus 5. Not a solution either. So that's the way you do it. Yeah, these are pretty small, and we'll build up from there. Now, when we draw a graph, what do you have to have? When we draw a line, what do you have to draw a line? What's that? Okay, let's see this. To draw a line, you need, okay, do we need XY coordinate? So here's 1, 1. Where's 1, going from the center? How do we plot 1, 1? Go right 1 and up 1. Can we draw a line there? Well, we can. We draw an infinite number of lines. What else do we need to draw a line? You need another point. So you need at least 2 points. There's another point. What's that location? This one's 1, 1. What's this location? Mhm. Now, since I have 2 points, there can only be one and only one line that connects them. So we can call that line 1, or we can call it, give this line a name A, but it has to have 2 arrows on top of it. You can call it either way. Say it's line 1, bless you, or call it A with a arrow on top, both arrows. So a line goes in both directions infinitely. That's why I put arrows at the end of it. So this is point 1, this is point 2. What do we call if it starts and stops between 2 points? What's that called? Hmm? Well, it's a line something. What is it called? Oh, if we have between 2 points, it starts and stops between 2 points, because a line goes on infinitely forever. What is it called if it starts someplace and stops? Very good. A line segment. Starts and stops at fixed points. So for the line, we used 2 arrows. For the line segment, it's still going to call it A, but here is just that one. That's the symbol for line segment. It starts and stops at a location. Or you could put dots at the end if you want to, but we just call it's the A bar. Okay. What about if it starts at a point and it goes on infinitely another direction? What? Array. Very good. We call that array. Starts at a point and goes on to infinity at the other direction. So here we have 2 of them. Either that or that. What's the difference? The direction is going right. Because if I'm going from P1 on out, that would be this one. So from here on out, that would be a that way. If I'm going from P2 this way, it would be a that way. If it starts at P2 and goes that way. So that's from P2 to negative infinity. Because it goes to the left. Equations of lines have three forms. It's just the way they're written, and they have different names for those. First one, we call it slope-intercept form. This is the one you're used to seeing. Y equals mx plus b. Because remember, we have our graph has two axes, x-axis and a y-axis. We have to find the x value and the y value. Where m is the slope, and b is what we call the y-intercept. Hence, slope-intercept form, because it's the slope and the intercept. And we're going to talk about this in a second also. The next form is the point slope form. And that one looks like this. Y minus y1 equals mx minus x. Now, why is that called a point slope form? Yes. Nope. We'll get to that. But yeah, but B's built in there. But also look at the name. There's no intercept in the name. Because the point that's inside here is x1, y1. So if I give you a point, you put those in place of x1, y1. And the slope is the m. You put those in there, and then we can go from here to there. That'll find us the slope, the intercept. Okay, so look at some examples here for the first one. In the first one, if I give you y equals 3x plus 2, what can you tell me about that line? The y-intercept. Now, if I say y-intercept is 2, what location is that? 0, 2. Because on the y is up and down. There's nothing on the x. It's up and down. So its location of the y-intercept is at 0, 2. So whatever this number is here always goes there with a 0 in front if you're looking for the intercept. And then the slope is more precisely. It's got to be in fraction form. 3 over 1, right. Because remember, how did we define slope last week? In words? Rise over run. So what this one says is go up 3 over 1. Because for a line to exist, each point has to have the same slope between them. If it doesn't, then it's not a line. Okay, what if I gave you this information? Put this information in the point slope form. What's y1? Y1 is -3. It's the y value. M is, that's what M is. X minus, what's x1? Just plug them in there. Whatever the x1 value is, goes in place of x1. Y1, notice there's a minus sign in front of there. So since y was negative, I put it in parentheses. Whenever you're inputting values, if it's negative, always put it in parentheses. Don't change this sign just yet, because that minus is supposed to be there. Y1 is -3, so it's minus -3. What is negative times negative? And there we have the point slope form. So far, so good. Convert the point slope form into a slope intercept form. In other words, if I gave you this, tell me the M and tell me the y intercept. If I gave you this, tell me the slope and the intercept. So M is 5, that's given. But the B, we don't know just yet, because we have to solve for y. We have to get y by itself. And then once you get y by itself, whatever constant you have there is your y-intercept. So what we have to do here is we have to first get rid of the parentheses. Multiplication first. 5 times x is 5x. Positive times negative is a negative. 5 times 2 is 10. Now we can get rid of the 3. How to get rid of the positive 3? So we have 5x, -10 minus 3. They're both negatives. So we add the numbers. So the y-intercept is at, the location is 0, -13. I feel like a comedian who just told a bad joke at a nightclub. It's so quiet out there. Questions? I know you're looking at it. Like, no, you have questions. If you want me to do more, just tell me. I have no problem doing more. Okay. Well, then I'll do another one. I'll do a bunch more in the next page. But I want to first finish the third form. The third form is called the standard form. The standard form looks like this. AX plus BY equals C. Good morning. Notice X and Y are both on one side. And X. So here's the only stipulation with the standard form. Whatever the value of A is has to be greater than 0, has to be positive. Or it can be, if it equals 0, it's just not there. But the number, if this is a number, it's got to be positive. All right, so let's look at some examples of all three of these. Actually, can anybody guess where all these three come from? We've done it already. Where did all these three forms come from? What equation did we do last week that all of these came from? What words is most common do you read in all three of those names besides form? It all starts from the slope equation. Show you how. It's pretty cool, actually. So we know the three formulas are here. Let's go ahead and start with the slope equation, and then we'll derive it, and then we'll do a 2 or 3 page worth of examples. So we know that the slope equation is y2 minus y1 over x2 minus x1 equals the slope, right? The slope equation. The first thing you want to do is move the denominator to the other side. How would I move the denominator? Which is the denominator? Yeah, because the top one is called the numerator. The bottom is called the denominator. So how do I get rid of the bottom number? Right. Because this is on the bottom, it's divided. What's opposite of division? Multiplication. So I have to multiply both sides by the denominator. I multiply whatever's on the bottom to both sides to get rid of it on the bottom, because this cancels with this. So I got rid of it off the bottom. Remember I said earlier, the minimum you need to draw a line was what? 2 points. So if you have 2 points, what can you find if you have 2 points? We have two. Yeah, but if we do that, then we have no equation. If we have 2 points, we can find the slope. Because if we have 2 points, we have x1, y1, x2, y2. With that, we can find the slope. So what we're saying here now, to find an equation of a line, you need to have the slope and you need to have a point. To find the equation of the line, EOL, you need 1 point and the slope. Because if I give you 2 points, then the first thing you have to do is find the slope anyway. Because if I just plug in those 2 points, what would I find? M. So you're gonna do it anyway. So let's go ahead and do it first. So what you need to find the equation is 1 point and a slope. That 1 point is x1, y1. Remember, you need a point and a slope. This one's M, and we'll call that x1, y1, because that's what we have in this equation. What do you do with x2 and y2? Those are the other points. How many points are there on a line? That's what we need to draw a line. But how many points are on a line? Infinite number of points. Because if you think about it, if you look at it, there's a point, there's a point, there's a point, there's a point. So there's an infinite number of points. So that's why we change y2 to y. And then x2, we'll just change it to x, because those represent all the other points in the universe for our line. Does this look familiar? It's the point slope form. So we started off with a slope, move the x's to the other side, we got the point slope form. So if I give you here's an example. Find the equation of the line in point slope form. Given 3, -5, and m equals 2. Find the equation of the line in point slope form. PSF. If I give you this point and that slope. Remember, here's the equation line. Do I have a point in the equation in my problem? Yeah. So if I have a point, though, that goes in place of x1, y1. And I have the slope that goes in place of m. So where does this number go? Yeah, this is x1. This is y1. So y minus, what is y1? -5. That's y1. Equals, what's m? X minus x1 is 3. Only thing we can do is just, since they're opposite signs here, since they're different signs, negative times negative is a positive. And there's your answer. That's all there is to it. So if you're given a point in the equation and a slope, that point goes in place of x1, y1. And the slope, whatever it is, goes in place of m. It's just plug and play. That's all there is to it. Let's do another one. I know how much you guys love negatives, so let's give you a bunch of negatives here. Find the equation of the line in point slope form. Given, actually, for equation line, point slope form that goes through -2, -5 with slope -4. -4/5. Yes. This one, because this is the point slope form. And that's what the question asks for. I know you think I have to do something. I have to go. I'm not done to the y. I'm going to solve for y, and that's what we're going to do next. But it specifically asked for point slope form. I guarantee you, almost half of y'all are going to do that in the first when you see this kind of question on the online. Read what it's asking for. If it wants it in point slope form, it has to be in point slope form. The y minus y1 equals mx minus x1. Okay, this question, put it in point slope form. It goes through the point -2, yes. Yes. Okay, because the equation is y minus y1 equals all this. What is y1? So it's y minus -5. Negative times negative is a positive. Yeah. So whenever you have signs next to each other, as I said earlier before you got here, is always do the signs first and then the numbers. Even if we multiply all these, you're gonna go positive times positive is a positive. Positive times negative is negative. Let's see. So always treat the signs and numbers separately. Actually, that's a good question because that's another check mark that people get wrong all the time. So with this one, we know it's looking for point slope form. So it's y minus y1 mx minus x1. Notice the way I do these problems, these examples. I always start with the formula that it's asking for. Now I plug in the values. Don't just jump straight into it without formula. You have nothing to base it on. So what is y1? What is m? Minus x1. Again, since these numbers I'm putting in, x1, y1 are negative, I put those in parentheses into the equation. Separate the signs when you can. It seems like a lot of work, but trust me, it's going to save you so many errors when you start doing this stuff. So the only thing we can do here, since we're looking for point slope form, negative times negative is a positive. So y plus 5. Negative 4 over 5. Here we have negative times negative again. So it's negative, negative is a positive. And there's our answer. That's as far as we can go. Now, to answer your question, why can't we go any further? We can. Actually, it's been here 1 hour. Let's take a break. Let me put on pause. Let's take a break. All right, so let's see now how this relates to the next one. What form is this? Point slope form. So let's go to the next form now. We had y plus 5 equals 2x plus 3. This is the point slope form. You're right. What we want to do is solve for y. Now, when you're asked to solve for something, the first thing you have to do, remove any parentheses. How do we remove parentheses? What operation gets rid of parentheses? By distributing that. by the distributive property. The distributive property is this. The coefficient in front, you multiply it to everybody inside. So a times x, a times y. It got rid of the parentheses. So in our case, again, treat the signs and numbers separately. Positive times positive is positive. 2 times x is 2x. Positive times positive is positive. 2 times 3 is 6. To get the y by itself, what do? Minus 5 to both sides. Remember, we have to combine like terms. Can we subtract 5 from 2x? No, because that's an apple, that's a banana. You can't take them, you can't subtract them. So we have 2x. Positive 6 minus 5. Is the answer going to be positive or negative? 6 minus 5. And there we have it. That's the slope-intercept form. There's the slope, and there's the intercept. Oh, you're shaking your head.
I remember that formula. I don't remember it at all.
That's true, because a lot of times nobody goes into that one. Because if I ask you to find the equation of a line, you'll jump straight to this one. And I'll show you shortcuts to that. But the other one works no matter what. It'll always give us the right answer. This one, we have to do some other stuff too. If I want to ask you to find the equation of a line. Okay, so we start off with a slope equation. From there, we did the point slope formula. Then from there, we solve for y. We get the slope-intercept formula. What's the third one? All right, it's the standard form. Find the standard form is move x and y to the same side of the equal sign. So what do we have to move? Yeah, so how do we get rid of the 2x on this side? We do the opposite. We subtract 2x from both sides. Those cancel. Are we done? No, because the standard form, a has to be positive. How do you get a positive? If a is the coefficient of x. If a is negative, then change all of the signs of the equation. So what that means, I change that sign, I change that sign, and I change that sign. Everything across the board, it changes. And there's your answer in standard form. So whenever the stipulation is the coefficient of the x, the number in front of the x has to be positive. Since it's a -2, I change everybody's sign. The way I do that is I multiply the entire equation by -1. But that's too much work. It's much easier to change all the signs. I change it from negative to positive. And the weird thing is, the next time we're going to see this type of equation is at the end of this course. In chapter 5, chapter 6. Because it's not really used that often, the standard form. So far, so good. Now, let's go back to the graph we had earlier. We had a point at 1. And we had a point at 5, 4. This is 0.2, this is 0.1. You could use a credit card or your student ID to make it easier. I just found a piece of paper and started using it as a ruler. So, given 2 points, what can we find? We did this last week. First thing we do, we can find the slope. What's the formula for slope? Over. Right. It's the change of y over the change of x. Because it's from so it's the distance between these two is x2 minus x1, where this is x1 and this is x2. So we know it's 5 minus 1, it's 4. So x2 minus x1 is 4. Or vertically, we're going from that one to that one. So that is y2 minus y1, which is 4 minus 1, which is 3. This is y2, this is y1. So there is your slope. It's the vertical change over the bottom change, denominator change, horizontal change. Always leave your slope as a fraction, not a decimal. Because this tells me a lot. What it tells me is from my first point, to get from my first point to the second point, what do I have to do? From here, I go up 3, 1, 2, 3, and then over 4, 1, 2, 3, 4. Do the same to the next one. 1, 2, 3, 1, 2, 3, 4. So it's going to be on line. Every point from there on out has to be on the same line. So leave it as a fraction. Unless, so, and if it's an integer, if it's 5, you know automatically it's over 1. Okay, so we found the slope. What else can we find? We'll get to that one, yes. EOL. We'll find the equation of the line. That's a little bit more complex because we just learned the 3 different forms. So whenever you answer that question, you have to know which one you're talking about. as default, we're going to use the slope intercept form, but not yet. We'll get to that one later. Another thing we can find if we give you 2 points. What? That's the equation of line. We can find the x-intercept and the y-intercept once we find the equation of the line. Just by having 2 points, you can't find anything else. We can find the distance. Or distance from point 1 to point 2. Or the distance between point 1 and point 2. How would we find that? Do we know any formula that deals with distance? Yes. The Pythagorean theorem. You've heard of it before. You've seen it on shows and things. That's the one that says a squared plus b squared equals c squared. The sum of the square of the two legs equals the square of the hypotenuse. The Pythagorean theorem only works on right angles. In other words, it has to be 90 degrees. So we'll call the horizontal, these are called the legs. That's the horizontal leg. And this one is the vertical leg. The legs are the short distances. This is called the hypotenuse. Use pencil and paper, don't use calculators. Now, yeah, you've seen this before. What it says is this. The length of A squared plus the length of B squared is equal to length of C squared. If I add those together. Length is a distance. Basically, if I'm going from point A to point B, if you're in New York City, you have to go down a block, up a block. You can't go through the building like that way. But if you were pigeon, you can fly over the building. So let's say this was 9 and this was 5. Together, if you had to walk, how far did you have to walk? 9 plus 5 is 14. This one has to be shorter than both of those because this is a direct line. But let's use our example. Can we relate this to our example? Well, notice here and here, we created a right angle. Horizontally, it's y2 minus y1, that equals 4. So we know that this one equals 4 squared. And the B, this is A, B is 3. So we know the lengths of these. So this is 4 and this is 3. What is 4 times 4? 3 times 3. 16 plus 9. But 4 plus 3 is 7. Is that 25? No. C squared is 25. The opposite of squared is square root. Again, next class, we're going to go through all the different functions. So to get rid of that, we square root both sides. The square root and the square cancel each other out. Always. So we get C square root of 25 is what times what is 25? 5 times 5. So this length is 5. So the pigeon only flies 5 miles. We have to walk 7 miles. So that is the distance between A and B. So we know the distance of this is 5. So far, so good. Let's put this in the formula now. You know, C squared equals A squared plus B squared. True? True. Remember, A was this horizontal length. Oop, that one. Its formula is that. So that goes in place of A, x2 minus x1 squared. What goes in place of B? The vertical one, which is y2 minus y1 squared. Remember, the hypotenuse is the distance. So to get the distance, we square root both sides. Oops, we square root both sides. So the distance, which is C, what C is the distance is the square root x2 minus y1, y2 minus y1. There's your formula for the distance. Which form? No, because the standard form is just ax plus by equals c. This is similar to it, x and y on the same side. But yeah, it looks like it, but it's not it. The beautiful thing about this is, remember, if I give you 2 points and ask you to find the slope, what do you have to do to find the slope? What's the formula for slope? This goes in here. Once you find the slope, you can just plug it in there, square it, plug it in there and square it. You don't have to do it all over again. Once you find it the first time, you're done. You just plug it in there. All right, so here's an example. Find the distance. Find the distance between -2, 5 and 2, 0. No, 2, 2. Let's try 2, 2. So it says find the distance. What's the formula for distance? So once you put the formula for distance down, x2 minus x1 squared plus y2, again, you have to first thing, always put down the formula what it's asking for. You have to know what the end result has to look like. Label the values x1, x2, y1, y2. What is x1? -2. This is 0.1, so this is x1. What's x2? This is 0.2, so this is x2. Y1, and then y2 is 2. Again, it's up to you, but I find it's much easier to plug in the points here if I have them defined already. Don't try to go straight from here to there. Again, it's easier, cheaper to buy a ream of paper than it is to repeat this course. So use all the paper you need. Let's start plugging and playing. What is x2? X2 is 2 minus -2. We put that in parentheses. Y2 minus y1. Once I took all those numbers, plugged them in there, now I do the math. Here, I have two negatives next to each other. It becomes what? So it's 2 plus 2 squared. 2 minus 5 squared. 2 plus 2 is 2 minus 5. Since 5 is opposite signs, 5 is bigger, the answer is negative. 5 minus 2 is -3. Very good. 4 squared. -3 squared. That's -3 times -3 is a +9. And that's the whole reason. That's the whole reason why we square the numbers. Because you cannot have a negative inside a square root. So when we square a number, it always becomes positive. -2 squared is -2 times -2, which is +4. 16 plus 9. And the square root of 25. And well, actually, we'll spend a whole session talking about radicals also, the whole rules about them, what they are and how to find them. And there you have it. What's the slope of this line? Hmm? Almost. You're one line too far down. Remember, slope is y over x, rise over run. -3/4. Very good. Very good. Because that's what we found inside here. This is x2 minus x1, which is -3. Y2 minus y1. This is x2. So it's -3/4. Everybody okay with that? Now, back to our picture. Yes, we can find the slope, which we did that. Equation of line x and y intercept, we'll do that in a second. Distance, we just did. There's one more thing we can find. What is the point halfway between there? It's called the midpoint. Six is midpoint. So that's the location of the point halfway between our two endpoints. The symbol we use for that is the capital M. Remember, it's a point. If it's a point, what does it have to have? All of my formulas. But what form does a point come in? X and Y. A point has to be X and Y. Remember, a point is that. So with the midpoint, we do the same thing. Remember, midpoint is halfway between point 1 and point 2. It's halfway between those 2 points. How do we find something halfway between 2 points? Mm-mm. The distance would give us the length, how far it is. We could find that, yes. But how we forgot the number halfway between? Just divide by 2? Now, what if I had the numbers 80 and 90? What number is halfway between there? How do I find 85? Very good. Add the two numbers and divide by 2. That's the same way you figure out your average of your grades. If we only had 2 tests, you would take the two test grades, divide by 2, that's your average, which is the midpoint of the 2 points. So for our x values, we have to add our x1 plus our x2 divided by 2. And then the y values, y1 plus y2 divided by 2. And there's your formula for the midpoint. So in our original example, what is the midpoint between our 2 points in our graph? What is x1? x2, y1, and y2. Remember, this is the x and y's relate to the points 1 and 2. One plus 5 is 6. 1 plus 4 is 5. 6 divided by 2 is 3. 5 divided by 2 is 2.5. Or 2 1/2. Or any one of those. Because this is the first time you can start using decimals if you want. Pretty good. So again, you notice how all of these deal with x1, x2, y1, y2. So once you label x1, x2, y1, y2, put it on the side, you can find all these points once you have the formula. So depending on what's being asked of you, always have that formula memorized. Have a sheet. Start keeping a sheet of formulas. Even though on the stuff I put on the computer, have y'all looked at that yet? Because I put the whole semester out there already also. I'll show you. If you go down here to course notes and videos, this is our notes and videos from last week. And this is for the complete course. You click that, it'll take you straight to this sheet. Math symbols, library of functions, but this is what we're going to do next week. But chapter 1, yes. Can anybody answer that? No matter what it says on the syllabus and everything, the due date is everything, because life happens. Everything is due by 11:59 p.m. the last day of the semester. No ifs, ands, or buts. You can get it done. Yeah, that's the reason I sent you all these, because like chapter 1, if you click that, that'll take you to this page. This has all of the lectures and videos, notes, and solutions of chapter 1. Here's a lecture video. And that's library of functions. And then here's section 2, section 2, 3, and 4. And then here are all the homework assignments worked out. So yeah, if you want to move on ahead, you're more than welcome to. Everything you need right there. And chapter 2, same thing. Everything's online. Your tests, your homework, everything's online. And again, as I said, if you need more, I put like 3 or 4 or 5. If you need more chances, then tell me and I'll increase the numbers. But I keep the highest score and don't cheat. So, and again, here's everything else you need. Here's the lecture video of chapter 2, section 4, lecture notes, the video and the notes. It's like this right here. You'll have the video of what I'm writing up here, but then I'll also you have a copy of what I'm writing here, so you can correspond to both of those. And the same thing with these solutions. I have of me working them out, and I have what I wrote there. So everything you need is right there. There's no reason anybody should ever fall behind in this course. Okay, let's move on. Let's talk about intercepts. What are intercepts? What is an intercept? Very good. Points where the line or the graph crosses the x-axis and y-axis. So we have two of them. We have an x-intercept, which I'm assuming x-int, where the line crosses the x-axis and the y-intercept, y-int, where the line crosses the y-axis. Where's the x-intercept? Very good. It's a location. The x-intercept is the location where it crosses the x-axis. And the y-intercept? Yeah. 0, -2. Right. Let me give you another graph. What's the x-intercept here? What's the y-intercept? What's the x-intercept? What's the x? You're not done yet. -2 what? It's a location, right? Yeah, you're right. It crashes here at -2, but it's a location. That x-intercept, it happens at -2, 0. How about the y-intercept? 0, 1. You notice for the x-intercept, what do they both have in common? Yeah. Y is equal to 0. So here are the steps to find the x-intercept. First, set y equal to 0. Then solve for x. That's all there is to it. Because for the x-intercept, we cannot have any y's. Set y equal to 0, solve for x. How about the y-intercept? What do they have in common? X equals 0. So set x equal to 0, and then solve for y, right? That's if I give you a graph. Oh, I have one more graph, actually. There. What's the x-intercept? What's the y-intercept? Very good. While we have these pictures here, tell me the slope. What's the slope of this one? For the top one. Nope. Nope. Why is it negative 1/2? Right. From this point to this point, I go down 2. So that's negative 2. And then I go over 4. It's not 2 over negative 4. It's remember, slope is a direction. So from here I go down 2 and then over 4. 1, 2, 3, 4, which is negative 1/2. You would have got the same answer. If you put 2 over negative 4, it's still been negative 1/2. But no, it's you have to, what is the slope represents the direction from one point to the next. So from this one to this one, what's the slope? Was it? Nope. One half. Because you go up 1 over 2. Because it's at negative 2 and this is 0. Yeah, because so every point from here on out, up 1 over 2, up 1 over 2, up 1 over 2. What's the slope of this one? What's that? Yeah, you go from here, you go up 2, over 2, which is 1 over 1, which is 1. It's a 45-degree angle. Now, more importantly, we also, these top two, this is the slope is negative 1/2, this is positive 1/2. You notice the direction of the lines. As you're going to the right, remember the bottom number always goes to the right. As x gets larger, what happens to the graph? Is it going up or down? So as x gets bigger, the graph is going down. So that's negative slope. As x gets bigger, the graph is going up. So it's a positive slope. That's what tells you whether it's going up or down. Just look as you're going left or right, is it going up or down? And remember, it's always going to the right. Because on a slope, only number that can be negative is the top number. It's either going to go up or it's going to go down. Everything else has to go to the right. Now you can also, if I give you an equation, you can also tell me the intercepts there. Think of how we just solved the other ones, what we talked about in the other ones. Go ahead, you're on the right path. Yeah, so our first step is set y equal to 0. So that disappears. The second step, solve for x. What do we do? How is 3 connected to x? It's multiplied. Yeah, it's coefficient, so it's multiplied. Yes. It's 3 times x. What's opposite of multiplication? So we divide both sides by 3. 6 divided by 3 is 2. So the x-intercept is at 2, 0. What's the y-intercept? Perfect. So that disappears. So we have 2y equals 6. How do you get y by itself? Divide both sides by 2. Very good. 6 divided by 2 is 3. So the y-intercept is at where? Because it's going to ask you a couple of times, what is the location or what is the x-intercept? You have to make sure you put it in the right format. Sometimes it'll just ask, the answer will be y equals 3 for the y-intercept. But if it's asking for a location, a point, it wants it at 0, 3. What form is that in? Standard form. What if I gave it to you in this form? What's that? Very good. What form is this? Slope-intercept. So this number here is automatically known as what? The y-intercept. So the y-intercept is at 0, +6. Now, mathematically, how do we find the y-intercept? Set x equals 0. So if it's in this form, if it's in slope-intercept form, the y-intercept will always be the constant number because the x disappears. Let's find the x-intercept. To find the x-intercept, what do? So we set y equal to 0. Solve for x. What do you do first? Subtract 6. Move the 6 to the other side. So -6 equals 3x. And divide by 3. Very good. So x is equal to, is the answer going to be positive or negative? 6 divided by 3. So the x-intercept is at -2, 0. Okay, now I'm gonna give you 3 equations. I want you to graph them for me. Why 3? Because one in each format. One in each form. One is the slope intercept, one in point slope, and one is standard form. All right, here are the 3 equations. You can graph that. Graph that. Let's do the first one. Okay, graph the first one first. Let me put this on pause. I love the way y'all were looking through notes and everything. Good. That's a good start. But let's not put it all together. What we have to do. Now, we have this equation here. Did we learn any method that we could use to help us graph this one? Yeah, first, if you can, always try to find the intercepts first. Whereas for the x-intercept and the y-intercept, for the x-intercept, set y equals 0. So let's get rid of the y. So x is equal to 2. So we know x equals 2. The y-intercept, get rid of the x. There's a negative in front of the y, so I change the signs. So I have 2y equals -6. And divide by 2, -3. Just find the intercepts first. If it works, it's great. If it doesn't, then we have to do something else. Then connect the dots. There's the graph. If it doesn't work, in other words, if we don't get 2 points, then just plot one of the points and then find the slope of this line. How do we find the slope of this line? No, we can't do that because we don't know those. Do we know any format that does tell us the slope? This one. Because let's say we only found the x-intercept. We could put a dot there. Solve for y, and that tells us the slope. Whatever's in front of your x is your slope. So from this point, we'd follow the slope and then get to the next dot. So now, this one's the slope-intercept form. When you have this, step 1, plot the y-intercept. This is the y-intercept, 1. From B, follow the slope. What does the slope tell me to do? Go down 2 and over 3. So from this point here, go down 2, over 3. And there's the graph. So if it's given to you in slope, I mean the point slope formula or slope intercept form, It's nothing to do. I mean, just plot the y-intercept and follow the slope. It's all there. Yes. Right. Because the slope is rise or sink over run. Rise if it's positive, go up if it's positive, down if it's negative, and the bottom is always positive. It always goes to the right. It tells us the relationship between each of the point of the line. Now, the third one is a little bit more complex. What form is this? It's the point slope form. Do we know the slope? Yeah, whatever is in front of that parenthesis 3/4. Now we have to figure out what our point is. What is our point? And here's something to say, it's going to be true whenever we start doing anything in parentheses. Whenever you have something in parentheses, this one is +2, it's opposite sign. So the answer is -2 in that one. This one's -4, so it's a +4. The point is -2, 4. So opposite of what is inside the parentheses. There's that one. They could also be in parentheses. Since that one's y-4, why is it the opposite? I'll show you. The point in this example here, the formula is x1, y1. x1, y1, because the signs are both minus. So if the sign is negative still, that is my y value. But if this sign changes, the only way a negative sign can change is if what? If the number behind it, yeah, if there's another negative sign. If the number behind it's negative. So what this one says is x minus -2. So that's how come it became a positive, is because from our formula, our x value is -2. Remember, the formula itself is y minus y1, x minus x1. If it changes signs, that means the number changes signs. If that's a x plus, that means the x value is positive, is negative. I'll put another one down in a second. So this one, the -2 and 4, that's our point. And our slope is from here up 3, 1, 2, 3, and over 4. 1, 2, 3, 4. So what is the point in this example? If that's negative, the answer is 5. If that's positive, that means this has to be a negative, -3. So always look what the formula is you start off with, and if the signs change, that means it's the opposite number inside there. This will become important in the next thing I'm going to show y'all. Circles. Because we're going to go the total opposite away from lines to circles. EOC. What is a circle? Try to define that without using the word circle. It's what kind of shape? A circle? Round, but round is a circle. It's once you see this, it makes a lot of sense. And yes. Exactly. Yes. Because we're going to be using the distance formula. A circle is an infinite number of points that are all equidistant from a center point. An infinite number of points that are all equidistant from a center point. Very good at defining that. Let's begin by this graph. Let's say our center point is in the middle at the origin. So let's say they're all 3 points away from the center point. Well, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then now all the other points that have to be the same. That's a circle. At any point inside there has to be 3 units away. Bless you. It all goes down to the Pythagorean theorem. Because every point inside this circle, they all come up with right-hand angles. The hypotenuse on all of those are 3. Remember, we said equidistant. That's the hypotenuse. That equals what we call the radius. So all of these points are all equidistant and they all form a right triangle. So what's the formula for right triangles? Yeah. There's your equation for, which is, this is fascinating. This was, the formula was used to describe right triangles. It's also going to be used to describe a circle. Talk about total opposites of each other. What's that? Mm-hmm. So what we have to do here, so we call the hypotenuse, we call that the radius, because the radius equals the distance from the center to the circle. Since it's a distance, we use the distance formula. Square root both sides. The radius is x2 minus x1 squared, y2 minus y1 squared. We've seen that before. It's a distance formula. But there's one thing different here. In the last one, we used to find distance between 2 points. Here, we have a fixed point. The center, a fixed point. It's located at what we call HK. So whenever we talk about HK, we're talking about the center points of our circle. These are the same as our x1, y1 points. So x2 minus h, y2 minus k, square root of all that. Everybody follow me so far? Now, instead of x2, those are all the other x's and y's on our graph. So the radius, the equation of our circle, is this. That's the equation of a circle. You can also look at it as this. What's the difference between the two? If you're looking for the radius, you use this formula. If you're looking just the standard form of an equation of a circle, that's the standard form. Let's do a couple of examples here and I'll kick you guys out so you can start your vacation early. Besides that, most of y'all are already dozing off.
The top one, radius.
Yeah, because notice R is by itself. So if you're looking for the radius, you have to have a point, because if I have to give you information about the circle, a center location and a point on the circle. If I give you that, then you have the X, Y, H, K. Then you can find the R. Otherwise, if I give you the R and the center, you can use this one. Here's an example. Find the EOC with radius of 2 and centered at -3, 1. Find the equation of the circle with radius 2 and centered at -3, 1. We'll go ahead and kill two birds with one stone because they go together. So there's the formula we'll be using. And all you have to do is just literally just plug the numbers in their current locations and you're done. This is center. So what are these locations? What do I label these as? H and K, because that represents the center. The radius was 2. H was -3. And K was 1. Negative and negative becomes a positive. And there's your answer. That's the equation of a circle. With radius 2 centered at -3, 1. Because all I did was I plug in the values for these and just simplified it. Didn't go any further. If I graph it, the center is at -3, 1. So I plot the center first. What's the radius? 2. The radius is 2. So from the center, I go to the right 2 spaces, put a dot. Go up 2 spaces, put a dot. Go to the left 2 spaces, put a dot. Go down 2 spaces, put a dot, and connect the dots. And there's your circle. There's your graph. So once you have the center and the radius, plot the center and the four directions, go to the radius and connect them. Okay, I give you this one. Tell me the radius and the center. Because remember, the formula is r squared equals x minus h squared plus y minus k squared. So r squared, this number is 9. We have to square root both sides. So the radius is 3. And the center is at, it's always opposite of what's inside the parentheses. -1, and there's nothing there, so it's 0. Make sense? Let me give another one like that. How about this one? 5 equals x minus 3 squared plus y minus 1 squared. The easiest one out of the two to find is which one? Center. The center is just reading the numbers. There's no work involved there. So what's the center? Yeah. 0 work. Now the radius, we have to do some work. Because remember, this is r squared equals. So r squared equals 5. Square root both sides. R equals square root of 5. So again, whenever you deal with these problems, these questions, always start off with the formula. The formula for a circle is r squared equals x minus h squared, y minus k squared. And no matter what it gives you, you can pair them up. And that's it for, yes. Leave it as radical 5. Okay, that's a very good question. I'm glad you asked. For example, which one's more accurate? Because that one goes on for infinitely. This one is until my pen runs out. So that's why I leave it as fractions or radicals. Same thing there. You should be able to do sections 1 and 3 right now. We just went over everything in sections 1 and 3. We didn't do section 2 because, again, I think it's out of sequence the way they're doing it, because section 1 deals with points and graphs, and section 3 deals with equations of lines, of how to interpret them, not to find them, but how to interpret them. If I give you 2 points, can you find the slope? Yeah, I hope. So if I give you an equation, can you find the slope? Can you find the intercept? So yeah. Section 2 is I have to give you a function sheet, which we'll do that next weekend. Other than that, you guys have a great, safe weekend.